I'm pumped to be here. Last DEF CON, so DEF CON 4, Mike and I were just roaming around. We didn't actually have an official talk, but it was super funny because everybody was talking about libp2p. It was around the same time that ETH2 was evaluating libp2p to adopt it and so on. So there was a lot of buzz, and we ended up realizing that people actually want to learn about libp2p, and people want to up their skills and understand what this thing is all about. So we ended up organizing kind of like a subversive workshop on the last day, very impromptu, communicated over Telegram, and very self-organized. We had a turnout of like, I don't know, 40 to 50 people in a tiny room, and we had to like move all the furniture out and sit on the ground. So it felt like the start of something very special in this marriage between Ethereum and libp2p. And I'm glad that we actually have official sessions this time. So it's great. We have, this is one of 2 sessions that we are running here at DEF CON. What I'm going to talk about is what has been up in the libp2p project over the last few months and what's coming next. A lot of super exciting stuff coming up next. So I have a lot of ground to cover. I'm going to go super quickly. I don't even know if I'm going to be done with this in time, but if I don't, come talk to me, come find me. I'm going to be around. The second talk that we're going to be having at DEF CON is about Gossip Sub. So a lot of people, Gossip Sub is an important protocol that is being adopted at the ETH2 project, and a lot of people have shown interest. So we decided to do kind of like a deep dive in Gossip Sub, about Gossip Sub. That's happening on Wednesday, room B10, and you've got the details in the slides. So I'm just gonna get started now. So I see a lot of familiar faces here. So who's actually a user, by show of hands, who's actually a user of libp2p right now? Okay, that's pretty cool. That's good. Who contributes to libp2p? Nice. Okay, we've got a team over there that's contributing actively to libp2p. That's awesome. Cool. So let's get started. As I said, we have a lot of ground to cover, very little time. And what I want to go through today, so who's actually pretty familiar with libp2p? Would you say, like, who's a 5 in libp2p, more or less? Okay, 5 and above. Cool, awesome. So I think the one-on-one is going to be important to go through today. Then I'm gonna talk about what we've shipped in the last few months and what we're actually building and what's going to be shipping over the next few months. So yeah, cool. So let's do little intro to libp2p. So libp2p is a modular peer-to-peer networking stack. It is, I like to call it the layer 0 of decentralized platforms, because it basically is, so if you realize everything that we're building here, everything that's getting built in this conference by teams that are attending this conference and so on, rests on top of unstoppable networks. If we don't have good peer-to-peer, rock-solid networking foundations, we have nothing, right? Because the very nature of everything that we're building is decentralized, and decentralized means that different nodes around the world, without knowing each other, collaborate across a set of protocols and across a set of processes. So libp2p is a modular peer-to-peer networking stack, which is essentially a composable. It's a composable set of building blocks to assemble future-proof peer-to-peer networking layers. It runs on many runtimes, server, browser. There have been experiments in mobile environments as well, and soon there's a team that's working on making libp2p run nicely on embedded devices. It originated in the IPFS project and is right now implemented across 7 different languages at different levels of maturity. There's a bustling cross-project community. Initially, it was created by PL, by Protocol Labs, and is stewarded by Protocol Labs. But by no means does Protocol Labs own the community or libp2p. At this point in time, at this day and age, it has become a public good, right? And it's being adopted all across the ecosystem. It is currently licensed officially under the MIT stack, but soon we're going to be transitioning under the MIT license. Soon we're going to be transitioning this to the permissive license stack, which gives you even more guarantees in terms of us being not claiming to hold any rights on top of over libp2p. So libp2p really hinges on this concept of decentralized process addressing. What is decentralized process addressing? The grand vision of libp2p is to provide the ability to locate, connect, authenticate, negotiate, and interact efficiently with processes around the world, no matter where they are, no matter what transport they're using, no matter what runtimes they're using, as long as their identity is cryptographically derived from, their identity is cryptographically derived from their public key. And libp2p really strives to make this happen in a seamless manner by taking care of NAT traversal, relay, packet switching, and a few other things that are important to make sure that different processes that are running anywhere in the world can find other processes in this global fabric that is the internet and interact with each other. Even as those processes relocate, roam, evolve, mutate over time. Right? So the concept of process addressing is completely juxtaposed to endpoint addressing, which relies on targeting a process by where they are in the world, by an IP address. Right? So libp2p, as I said, is a stack of composable building blocks, and these building blocks are transports, multiplexers, secure channel, peer discovery, PubSub, traversal, and several other things that are not even mentioned here. So think of libp2p as a toolbox to assemble the networking layer of a decentralized platform from composable pieces, kind of like a Lego puzzle, right? These elements plug into each other via abstractions, and each of these elements can have multiple backend implementations. So for example, we have multiple transports, TCP, Quick, there is a Bluetooth transport that's up and coming, we're working on UDP, so there's a number of backend implementations to each of these pieces. So that's kind of like what I have. I have very little time, so this is what I have for an intro. And now we're going to talk about what we shipped in the last few months. And this is super exciting. So libp2p has 7 native implementations, which are not shipped, they're shipping continuously, right? Nothing is ever done in this world, right? What's cool about this is that each implementation really is backed and supported by a different provider, a different community, a different team in the ecosystem. And these teams are actually working. Hey, we've got some here, so we've got, okay, raise your hands. Status over there is implementing libp2p. We've got the Signal Prime team over there that's implementing Rust libp2p, that's working with the Web3 Foundation to implement Rust libp2p. Do we have others? I think we have the Java team around. Well, we've got Go and JS over there. This is pretty cool. So what's cool about this is that all of these implementations actually follow the libp2p specifications. So they're interoperable with one another. They are at different levels of maturity. So the 3 most mature ones that we consider are JS, Go, and Rust. And PyLibp2p, JVM, and NIM are mostly driven by the Ethereum 2 project. And CPP libp2p is driven by the Polkadot project. So this is pretty cool. And what's great about this is that each implementation, in a way, also targets specialized environments, right? So in the case of NIM libp2p, they are making a strong effort to target embedded and constrained devices, right? In the case of JVM libp2p, right now in the current version, it is a Java implementation, but in the next version, it will be very geared towards Android as well, right? So this is pretty cool. I'm very happy about this. Right, so in terms of adoption, the adoption of libp2p over the last few months has somewhat skyrocketed, and it's been kind of like a network effect. It's been amazing. So what's cool about, so here you've got like a few of the adopters, some that are worth mentioning, of course, Polkadot, Ethereum 5.9 the kind of like the top ones over there, and then there is Xerox that's doing a lot of awesome stuff, OpenBazaar that have created an onion transport for libp2p, and that's what's cool about all of this traction, and basically having a bunch of communities that when you look at how they would have built their networking layers from scratch, they would have looked a lot alike one another, right? Because they all share the same concerns, right? So connectivity, addressing, peer discovery, NAT traversal, these are things that are common across the ecosystem, right? So there's no point reinventing the wheel at each of these projects. And what's cool is that all these projects are now collaborating in the libp2p open community to pull their brains and the hands to build a rock-solid networking foundation. And what's great is that most of these projects are actually contributing actively so not just using the technology, but actually contributing. A few weeks ago, we also saw the 7-way interop liftoff of the ETH 2.0 project. So a bunch of teams actually locked themselves up in a few cabins in Canada and came up with a network of a libp2p-based network of all 7 clients built in different languages interacting with one another. And this is impressive. This is a tweet that was super popular by Johnny Ray, who I don't know if is in this room right now. Yeah, not right now. Cool. So a few weeks ago, we also launched DevGrants, and we made, so DevGrants is the place where we're going to be publishing, and where we're going to be publishing work that we would like to get done, but it's also a collaborative space for different projects across the ecosystem to publish items that they would like to ship in the B2B, and co-fund those items and pool funds together to make sure that those happen. And at one point, we're speaking as well with a few teams that are gonna help us fund much of this work via DAOs and a few other things. We also awarded a bunch of bounties at ETH Berlin, and that was hugely successful. We've also shared talks and specs. This has been a long-standing issue for the libp2p project. Thanks to everybody who stuck by us during the dark times while we didn't have good conceptual docs. We now have an amazing docs.libp2p.io website. We're engaged in a full specs rewrite to make sure that the specs actually match and they're accurate with the implementations. We've created a specs maturity cycle. We're defining an RFC process, so we're maturing a lot in terms of the things that are just not code, right? So there's more things in a project that are not just good. We've launched the discussion forums as well, so you've got discuss.libp2p.io, so if you have any usage questions, if you want to start a discussion about things that are not necessarily bugs or change requests and so on in code, this is the place to go, not really GitHub. And we've shipped a bunch of features as well, right? So this is just a list of the ones that came to mind. We've got AutoNat, Auto-Relay. We created a Auto-Relay experiment, so we launched an Auto-Relay experiment at IBFS, gathered a bunch of learnings from that. TLS 1.3 spec, and the implementation in Go libp2p, quick transport with draft 23 support, WebRTC direct transport, which was actually promoted and created by the folks at 0x. I think they're here. Browser-based wasm deployment, so browser-based wasm deployments of Rust libp2p and Go libp2p as well, with a lot of support from the 0x guys, who I see in the room as well. We've got gossip support that was created by the guys at Sigma Prime in Rust. So taking the reference implementation from Go libp2p and porting it over to Rust, as well as the guys from ChainSafe who did the work for JS libp2p. There they are at the back. Amazing. We also shipped the libp2p daemon. We have refactored the interfaces in Go libp2p and adopted Go mod. There is a up-and-coming Bluetooth transport that has been created by a team, a French team that's called Verti, who are building a decentralized peer-to-peer offline-first message application, and they've got that running on Go libp2p, shipped in iOS, and of course we've implemented any stability and performance fixes across the board. So that is what we've shipped so far in the last few months. The things that actually came to mind. There have been a lot more things that didn't come to mind, so sorry if I did mention some that you think are relevant. And now I'm going to talk about what we're working on and what's on the roadmap for the next few months. So number one priority, not just for us, but for a lot of projects and a lot of teams across the board, is testing at scale. And this has been a recurring topic. Whenever I speak to a team, they're like pretty confused, and they always ask about, hey, how are you testing IPFS? How are you testing libp2p at scale? And what are the techniques and so on? So this has become a bottleneck for us. We want to make sure that every single release of libp2p and IPFS and other projects that we put out there is well, so the improvements or the deterioration of each release and each commit is well quantified. And for that, we need a platform, which we're calling the Interplanetary Test Ground, to be able to create distributed and reproducible tests that hit magnitudes of 100,000 nodes, right? With simulated network conditions. So this is going to be a platform that is currently in development. We have architected this platform. We're racing towards it. And what we want to make sure is that it's tightly integrated with the engineering lifecycle. So basically, there's no use in having a platform where you have to do things manually every single time, right? So we want for every single commit of libp2p and IPFS to be subjected to a battery of tests of different kinds, right? So comparative testing. How does this commit compared to a previous commit or to a previous branch? How does this PR deteriorate or improve the status quo in terms of how my node behaves, what are my runtime characteristics, and also in terms of emergent network behavior as a result of deploying that PR in a network of 10,000 nodes, 100,000 nodes, right? We want to be able to do things like chaos testing, interoperability testing, so being able to take, for example, a particular proportion of nodes that are running IPFS or libp2p version whatever, 50% that are running this version, 20% that are running this version, and 10% that are running another version, and understand how that combination actually plays out in terms of performance. This is what the architecture is looking like. If you want to follow this effort, if you want to track what we're doing, make sure that you watch this repo, IPFS test round. It is right now under the IPFS umbrella, but it's probably going to be moved to the libp2p umbrella at one point because it's way lower in the stack than IPFS, or even a separate top-level project. Another thing that I'm super excited about, that we're working actively on, is instrumentation. So a lot of teams have asked us for better observability and essentially the capability to X-ray into what the libp2p stack is precisely doing in real time. So we're currently laying the groundwork by taking a data-first approach, right? So yeah, it would be awesome to create ad hoc visualizations about things that are happening in libp2p, but really the scalable way to build this is to tap into the inner guts of libp2p and expose a fire hose of instrumentation data via a standard protocol, such that any implementation of libp2p, by adopting that standard protocol, will render itself to being visualized and being inspected by a common framework, right? So the next step, so we're focusing on building that fire hose, an introspection protocol that we're drafting, and the next step is to create a binding framework that consumes that data in a browser, creates essentially a reactive state repository on the browser that React D3-driven visualizations can subscribe to and visualize data, whether it's a recording of a slice of time, and like where we want to give people the ability to move backwards and forwards through time, so that you can, if you want to debug a particular situation, you can start up a recording, take a dump, and then load it into the browser and visualize and move through time, as well as watching the activity of a node in real time. So yeah, we plan to release a browser library for developers to compose reusable visualizations, and we definitely hope that this will kickstart a catalog of reusable visualizations across the board that are compatible with all libp2p implementations. And by the way, this project is codenamed Phantom Drift, so if you see those terms, now you know what it's about. So a few other things that we're going to be working on, that we're actually working on, are message orientation. So this has been a long-standing missing feature in libp2p. So we're intending for libp2p to become an entry point. So for libp2p's entry point to become a factory of stacks from which you'll be able to create different kinds of hosts. We're working on NAT hole punching and direct connection upgrade. So we already have UPnP and NAT-PNP port opening support, but and we have the auto relay and auto NAT subsystems that are capable of sensing if you're running behind a NAT and automatically starting up a connection with a relay and advertising those addresses to the rest of the world so that you can receive inbound connections, but that is super inefficient. And what we need to do is move to a place where we use that relay connection as an embryonic connection to do signaling between various peers to start to initiate a hole punching procedure and hopefully be able to hole punch, right? We're going to be working on robust pervasive quick support as well with TLS 1.3, and this is important because this combination of protocols is what's used in HTTP 3 as well. And if we make libp2p run on port 443, this means that we basically have a high chance of being a lot more censorship resistant than we are right now. A few other things that we're working on: negotiation, protocol negotiation. I won't go too deep into this, I have very little time. So multi-static 2.0, if you hear this, there's a bunch of features that that are necessary for ETH 2.0 as well, so they're super high priority for us. We are creating new secure channels, DLS 1.3 and noise handshakes. Noise handshakes is going to be using noise pipelines, which uses a combination of optimistic scenarios with graceful fallbacks when the key is not, when the key has rotated on the other end. We're going to be working on TLS 1.3 in all languages. We currently have support for Go, and there are some roadblocks in JS and Rust, so we're going to be sorting through those. And and basically, yeah, so a few more things here to mention: language-specific improvements and maturity, PubSub evolution. So make sure that you come to the Gossip Sub session on Wednesday, which is at 2:55 in room B10. Because we're going to be talking about some of the things that are coming down the pike in terms of where this is heading. We're going to be talking about something called DECENTRALIZED, which is the future generation of Gossip Sub. More evolution, so hardening the DHT, which is a critical thing right now for us. And this is dependent on the test round. We are aiming to get even better specs, so we're aiming for 100% accurately specced, and there's a contributor and there's a peer that's working actively on this. Other topics, CTK, onion routing, reputation management, these are things that are ideas that we're developing in our heads, and we hope to flesh out over the next few months. Also wanted to showcase what I talked about earlier, the Bluetooth transport in Go libp2p, which was developed by our friends at Bertie. Unfortunately, it is still closed source, so we can't demo it, or we can't. There's no public access to the code, but that will change hopefully shortly. And that's pretty much all I have for today. So that was super rushed, a lot of content to share. And if you have any questions, make sure to hit me or to ping me around. I'm going to be roaming around. Make sure that you come to the next session that we have about Gossip Sub, which is tomorrow at 2:55 in room B10. And make sure, if you're excited about libp2p, like we are, and a lot of people in this room are, make sure to get involved, either by shaping the future, contributing to the specs, by hacking on meaty things, looking at the dev grants and taking on some of that work. And if you just want to contribute, on particular things, then make sure to watch the Project Rebels. So those are the contact details. If you don't find me around and you want to talk libp2p, make sure to ping me on those networks. Cool. Thank you.